We're going to continue to talk about quadratics. We're not going to go into super detail in the quadratics like a lot of factoring or anything, but what we are going to do is make sure that you understand the basics of quadratics. Quadratic is an equation that is in a standard form as ax squared, a being any number, plus bx, again, b can be any coefficient, plus c equals 0. Okay, and so one of the things I'll point out at the very first here is that, wait, don't. I'll get you some in a minute. Okay. But those are like, I know what I'm doing there. Just leave them. Okay, one thing I want to point out here at the beginning is when you have a quadratic and we're going to work with it some way, we need to make sure that it is in the order of descending exponents, which means the largest exponent goes first. Here's 2, and then this is an invisible 1, and then this would be x to the 0. So you can see that the exponents are in decreasing order. That needs to be that way, and it needs to be equal to 0 before you can do any kind of calculations with the quadratic. So this is an important thing to go by when you are getting ready to use a quadratic. Now also, you're going to find out that we're going to use the coefficients. Now again, these are numbers, okay? We're going to use these coefficients when we start to solve problems. And so right now, I want you to understand that we are going to be picking out the value of A, the value of B, and the value of C. And we're going to, this will depend on actually the sign too. Let me give you an example. If we have 5x squared minus 2x minus 3 equals 0, then the coefficient in front of the x squared is our A, see? And so A is a positive 5, not a 5x squared. It's only the 5. Now the B you need to be very careful about because it is in front of the x. There's a 2 in front of the x. But the sign goes with it. So B is a negative 2 and C is a negative 3. Okay, and we're going to be using this today, but I want to point these things out to you. I'm going to go back to the graph and point out the parts of the graph, okay? And then we might do 1 or 2 on the pages that I've already sent you. But I want you to understand where we find our A, B, C's. We're going to be using those in about 5 or 6 minutes. Okay, does everybody have this written down so that I can erase it? I need room. Okay, 3, 2, 1. Okay. Now, the graph of a quadratic is what we call a parabola. It's a parabola. Now, a parabola looks like a U, but it continues to move out instead of straight up like a U would be. This is a parabola. It can also go down. These are parabolas. They can occur anywhere on the graph, on the coordinate graph, okay? And we'll talk about that moving around too. Now, there is a parent function, and this is for you to have in your notes and refer to later. There's a parent function for a parabola, and this is going to be, hang on, yeah, y equals x squared. Okay, now this is called the parent function. we're going to extend this a little bit. Parent function. Now, you know, a parent is where we come from, right? There was first a parent, and then there were changes and whatever, and it became you, right? So this is the parent function, and the parent function will put the parabola starting at the origin and its arms moving up. This is what the parent function looks like. Later, we can have all sorts of parabolas in different spots on the graph. But this is where everything begins. Okay, we're going to extend the parent function a little bit because you'll need to know it later. Uh-oh. I should have looked. I have it written down. Oh man, I'm gonna have to give you that later. I think I don't want to mess it up. Okay, so for today, I'll tell you about it tomorrow. Okay, y equals x squared is the parent function, and that creates this parabola right here. That is this. Any changes you make to this will cause it to move around, and we'll address that later this week. Okay, now the parts of a parabola. This is something we also talked about last week on Thursday. We said if we have a parabola, the place where the direction changes is called the vertex. So even if I have an upside down parabola, where the direction changes is called the vertex. Oh, there's Josh. Hi, Josh. Are you here, Josh? Oh, it's Jesus.
What?
I thought it was Josh.
OMG.
But he doesn't have any audio on. I don't know if you can hear me, Jesus, but I can't hear you. Okay, where the direction changes is also called a vertex here too. Okay, it's where the direction changes. It's called the vertex. Now, we also talked about, they'll ask you about min and max. Min is the minimum point. So that means the lowest point. So the vertex of this kind of parabola will be a minimum. And sometimes they call it a min, but it's a minimum. Okay? That's when the parabola is like this, and it makes sense because the vertex is the lowest point on that picture. So the same applies here. The vertex is the highest point on this parabola, and so it's a maximum. Or they call it a max. Here's a little note.
Your YouTube videos go in and out.
The what?
Your YouTube videos, they go in and out.
Is that right? I don't know what causes that.
On that last video you did post on,
Mhm.
it had no sound to it.
At all, the whole time. I don't know what's going on. Okay, let's move on. Now, remember those ABCs. I'm going to tell you how to find the vertex of a parabola from the equation, okay? And you're going to have a worksheet on how to do this today. You're going to be practicing this. So let's say you have negative 5x squared plus 4x minus 2 equals 0, okay? So let's find your ABCs. What is the value of A?
-5.
Negative 5. Value of B?
It's +4.
Positive 4. And C?
It's a -2.
Negative 2. That's wonderful. Now that you know your ABCs, and you'll be picking those out a lot, then the way that you find the vertex is to take -2 times B over, well, no, Deborah. It's negative the value of B over 2A. There we go. Negative B over 2A. And that will give you the X part. It'll give you the X part. Now, this particular parabola is going to go like this, okay? And the reason it goes like that is because there's a negative out front. So we're going to be finding the maximum, which is the vertex, okay? Now that point, we know if it's a point on the graph somewhere, it has an X value and it has a Y value, right? Well, this will find the X value. Uh-oh, I wrote something over there that they can't see. There we go. Let me see it if there's any chat. Oh, I'm not finding Jesus anywhere. Okay, so to find the vertex here, we're going to use this formula to start. So I'm going to say X is going to equal, this is the X value of the vertex. X equals a negative whatever B is. What's B?
4.
4 over 2 times, what's A?
Is 5. -5.
Negative 5. So the X value for this quadratic, and I just made it up so it's going to be weird, is -4 over -10. The negatives cancel, and it simplifies to 2/5. 2/5. Okay? So we know the first part of the vertex is a +2/5. Okay? Now, there is another formula for the y part, but what I do is just plug in your x part everywhere there's an x. Okay, so now I have -5 times 2/5 squared plus 4 times 2/5 minus 2 has to equal 0. Well, we'll do that for now. So now I have -5, and we have to square this fraction. When you square a fraction, you square the top and square the bottom. So I have 4/25 plus, again, this is weird because I made it up. So this comes out to be 8/5 minus 2 is going to be our y. Okay, we're going to keep on moving on. And so if I take -5/1 times this, 5 is going to cancel, make this a 5. So it's a -4/5 now. A -4/5 plus 8/5, a +4/5 minus 2. And one more step. Let's see, that'll be 10. So y is going to be a -6/5. I'm pretty sure. And so that is our y. When you plug the x in. Is it driving you crazy yet? I'll pick one off of your papers and we'll go from there. Not yet. Okay. I got your message, Jesus, and good. I just can't hear you. Okay, so this is how we find the vertex of a parabola. We take the equation and then find our ABCs and put them in that equation. I'm going to give it to you. Let's do one that came off of your paper so it didn't come out. Here we go. Pardon? Oh, thank you. I like it. Thank you. That is very unique, just like you, you know. Did y'all get this?
Yes, I wrote it down.
Okay. So I'm going to give you one off of the paper so you will know exactly what it says for you. And these are papers I'm going to send to you. You do not have these. Okay. This is exactly what it says. Find the maximum or the minimum value of each quadratic function. The first one, this is number 1. So you can write this down so you'll have it for your paper. X squared plus 10 plus 19. And because this is a positive here, this parabola is going to look like this. It's going to point up because it's positive. And so our vertex is going to be a minimum. So on number 1, it gives you the equation. It gives you the equation and then it says minimum value. So it's telling you it's going to be a minimum, but you all need to know if this is a positive, it's going to be an up parabola. If it's a negative here, it's going to be upside down and it'll have a maximum. But on this paper you're going to work on, they'll let you know. So let's make sure first that this quadratic is in the standard form that we need. Here's the exponent 2, then 1, and then 0. So it is in order. Let's find your ABCs out of this equation. Now, what is the A, guys?
Would it be?
Oh, no, this f of x right here
Formula, right?
is the same as a y equals, okay?
Is it gonna be the 10x? Or?
It's the coefficient that's in front of the x squared.
Yeah.
What's in front of the x squared?
No, 1.
Yes, it's an
Oh.
invisible 1. So A, the value of A is 1, okay? Value of B,
10x.
10.
no,
10.
just 10,
10.
not the x, okay?
And then 19.
And 19. Are any of them negatives? You always double
No.
check and look.
They're all positives.
All right, now to find the x of the vertex, the x of the vertex equals negative b over 2a. Negative b over 2a. Now, I don't think that's on your formula chart, so you're going to need to remember it, okay? Negative b over 2a. I'm sorry.
I'm trying to read your formula.
Did I hear you guys say something? Isabel, did you say something?
No, ma'am.
Okay, you guys can hear me and everything's fine, right?
I'm okay.
Okay. Jesus said he can hear me,
Yes.
just doesn't have any audio to talk to me. All right, so x is going to equal a negative whatever b is. What's b?
10.
10. Remember, the negative comes here because it's in the formula.
Yeah.
Then whatever b is. If b was a negative, you would put another negative there. And then over 2 times whatever a is, which gives you a negative 10 over 2, which simplifies to a negative. Okay? Now we have to remember what we just got. We just found the x of the vertex. So our point has an x and a y. We're going to have to find both of them. So negative 5 is the x part. Okay? Now the way that we find the y part is we're going to take the value that we found for x and plug it into this formula. Remember, the f of x
Yes.
means the same thing as y.
1.
Okay? Y.
Oh, y, yeah.
Y. So now we have y, this is the y of the vertex, equals
2.
1 squared,
Oh, yeah. I see.
okay? Because we're putting, oh, no, sorry, negative 5, right?
Yes.
Negative 5 was our x. Negative 5 squared plus 10 times negative 5 plus 19. So whenever we do our math here, we're going to know what the y coordinate is. We had found out that x is negative 5. Now we're plugging that negative 5 that is x into all the x's so that I can find y.
One more of these things. I have trouble.
Okay, so y is going to be equal to 25 minus 50 plus 19. So y equals negative 25 plus 19. So y is going to equal a negative 6. And that's the point. That's the minimum point of this quadratic. It's the minimum point. It's also the vertex. Minimum and maximum are the vertices, okay? Vertex. How close are you to grabbing onto this? It's Monday. So you think you're going to get it?
It would take me a while, but I ain't gonna lie.
Okay, let's try one more then. I'm going to give you 2 of these pages. Wow, we've got 400 of them. Okay. Here's one. You're going to have 2 pages of this so you can make sure that you can remember how to do this. You should get pretty good. So on the second page of this, it says, oh, that's not it.
There's 2 different ones.
Yeah, it's this one. Okay, sorry. Oh my. Nope, that's the page we're doing. You're only going to get 1 page. It's Monday. Remember last Monday? It was terrible. Okay. Negative 16 x squared plus 24x minus 5. And it says, oh my gosh, you guys sound awful. It says find the maximum. Find the maximum. You poor babies.
Am I gonna have to cover myself?
Find the maximum. Okay, now remember that the maximum and the minimum.
Is the higher one.
What?
It's the higher.
Yes, yes. But I was going to say it's also the vertex, right?
Yes.
So when they're talking about maximum and minimum, they're talking about the vertex. Now, maximum, yes. It means it's the highest point, right? Okay. And because of that negative, we know that the parabola is going to be an upside down parabola.
Yeah.
So that makes the vertex the maximum. We're really glad of that, right? Okay. And the vertex will have an x and a y value. So now we need to figure out what the x part is first. Okay? Remember that f of x is the same thing as y. Okay? And is this in standard form?
Yes.
Has the largest exponent, the next largest, and then nothing at all.
Yeah.
Okay. So what are our ABCs?
16, negative 16,
Negative 16,
24,
24.
and a negative 5.
Very nice. You didn't miss the signs at all. These are the ones that we're going to put in our formula to find the x of the vertex. So we're just going to find one piece, negative b over 2a. So what am I going to plug in the top? What does the top look like?
Negative 16.
Try again.
24.
Negative 24
Okay, yeah, 24.
over 2 times
16.
-16.
negative 16. And that will be a negative 24 over a negative 32. And when we simplify that, we know that the two negatives cancel each other out. Divide the top and the bottom by 8, and we have 3/4. 3/4 will be our x. So the x, the maximum right here, is going to be 3/4. And then we have to find our y. So y equals, okay, we found our x right there. Okay. Y equals, and I'm coming back to my original quadratic, y equals negative 16, but now I know what x is. I'm going to plug in for my x, 3/4, and it has to be squared, plus 24 times our x, again, 3/4, minus 5. Okay, and here we have to square first before we do anything. So we have negative 16, I'm going to put it over 1 because we're going to multiply by a fraction. When you square 3/4, you're going to have 9 over 16. And then plus, let's do 24 over 1 times 3/4 minus 5. Our 16s are going to cancel and make 1s. So I have a negative 9. My 24 and 4 are going to cancel. So I have plus 18 minus 5. So my y is going to equal 4. Is that correct? Negative, being positive 9 minus 5 is 4. And we'll check it because I have a paper. Aha. Okay, on your homework paper, this is correct. But sometimes you will see the answer like this because this is the point that is the vertex. It's a done deal. But if they want to know what the highest value is, remember that if we would graph this and we go, we need a different system here. Okay. If I would graph 3/4, 4, here's 1, so 3/4 is here and 4 is right here. Okay. And then we have our parabola coming down somewhere. And then the point of the vertex is 3/4, 4. That means the highest that we went, was 4. So if they only have one number that says the maximum, find the maximum, it's always the y. Always the y, because the y goes up and down. So the highest on the y is 4. Do y'all see? Okay, you have your Monday faces on. Okay, now let's move to, I think you guys have enough on vertex to practice it. Now we're going to move to one more thing, and then I won't overdo it. We're going to move to x and y-intercepts on a parabola. X and y-intercepts. If you'll remember, we've talked about intercepts before. Intercepts are the points where the actual graphing picture crosses one of the axes. So here's the x-axis and here's the y-axis. So if I have a parabola, I want to do more than that. Let me do more. Okay, let's say this is our parabola. Okay? The x-intercepts are where the picture crosses the x. So this point is an x-intercept. This point is an x-intercept. So this will have some point, an x and a y, and this will have an x and a y coordinate. Then okay, these, let me write these for you. Where the picture crosses the x-axis, these are called x-intercepts. X-intercepts. Now, a parabola, most of the time, will have two x-intercepts like this. Here's an example. If it crosses here and here, there's the x-intercepts. If it crosses here and here, there's the x-intercepts. But it's possible for a parabola to have one x-intercept. If it comes down and just touches the x. Do you see it just touches one time?
Mhm.
So a parabola could have just one x, or, believe it or not, it could have no x-intercepts, like this. And you see that it's never, ever going to touch the x-axis. So there are no. So on x-intercepts, this is the most common. The most common is you're going to have two. But there could be a parabola with one. There could be none. Okay? Y-intercepts. Notice that I didn't put an S on a y-intercept because any parabola is just going to have one. And here it is for this one. There's the y-intercept. This y-intercept is right here. This y-intercept, remember I told you this doesn't go straight up, it continues to go out. And so sooner or later, it's going to cross the y. It's going to have a y-intercept. This one will sooner or later will have a y-intercept. Okay, every parabola that you're going to be working with will have one y-intercept. It could have 2, 1, or 0 x-intercepts. Okay, now how do we find them? It's actually pretty easy. You need to know something else. Just know this for today, because, just a minute. Yes, you need to know some more before I teach you the x-intercepts. Oh. Okay, you know this about a parabola, right? Okay. So now today we talked about how to find the max and the min, which is definitely a vertex. And you know what x and y intercepts are. I think we're going to stop there. I think so. I think we're going to stop there. Now, one thing that I said last week, and we need to say it again, is on the x-intercepts, which we said are the points where they cross the x. These are called x-intercepts. But they are many times called zeros. Same thing. If it says find the zeros, they're wanting you to find where the picture crosses the x-axis, okay? They may call them roots. Find the roots. Again, it's only finding this point or solution. Find the solutions. All of these, if your instructions say this, all they want to know is what are these points. Is everybody good? How about you, Isabel?
Yes.
Okay, that's how far I'm going to go today, because to find the x and y intercepts, you need some more information. And I don't want to do that to you today. So, Jesus, how are you? Did you understand it? Do you want to chat me out and tell me? Any questions in here? Okay, we're going to be finding vertices. Okay. Okay, I got your message, Jesus. Okay, then I will send you all the papers that we get out here in class today, and then I will see you tomorrow in the Zoom, and we will move on. Okay, any questions?
Okay.
And I see you're okay.
Okay. No.
You know I love y'all. Okay. We'll see you tomorrow.